Homework. Answers. Nope. Key. Yes.
Can I have the homework from last class?
Sure. Let's see how you did. Okay. So not too big of a lesson here. We decided this was exponential. If f is increasing function of all table values, but use a table to determine if it's multiplied linear, quadratic, or exponential. I don't think that's the only way, but for now, that's for sure the only way you have to determine. You don't ever have to determine if it's cubic or quartic or anything like that. It's just one of those three. It's really common sense to know if it, I think I say that. The difference between linear and the other two, sometimes quadratic looks exponential, and that gets a little bit hairy, but most time they make it pretty easy. Talk to me. This is not what you did? Well, cuss. I was worried about that. Here I am. I had a bad teacher today. Bad teacher. Bad teacher. I did not prep. Oh, that's why, because I'm guessing we have, let's see, topic, key. Let's look at this one. Is that what it looks like? Okay. Well, piddly fart. How do I? Okay. Oh, that's probably too big. Okay. So you plot those points. First one's linear. Now we're back on. Now everybody's on the same page. Beautiful. They thought number 2 was exponential. However, again, it could look somewhat quadratic, but only because really you're only seeing half the quadratic, right? So if you only see half the quadratic, that would have to make it exponential. Because we don't know if we're seeing half of it or not. You'll kind of follow what I'm saying on that. Like if there were a couple points over here up, then it would be quadratic. Okay? But that starts low, goes high only, so that has to be exponential. Third one, quadratic. That one does go low, goes high. Or starts high, goes low, goes high. Fourth one, exponential. Again, starts high, goes low, and it doesn't ever. Now, it doesn't have to be perfect, right? We could have 1 point, maybe, oops, sorry. We might have one, good gracious. Come on. You might have 1 or 2 points up, but it's got to jump significantly up for that to be quadratic. It should be fairly common sense. Okay, number 5. This shows the residual plot. The quadratic regression was used to model a data set. So you got to read these really carefully, and do you understand what residuals tell us? So we have a quadratic regression. It was used to model some data set. The residual plot is above. So immediately I look at that residual plot and realize whatever I did was bad because this is curved. Okay, so whatever I did was bad. Which of the following statements about the appropriateness of this model is correct? And that one's D. A quadratic regression model is not appropriate because the residuals show a quadratic pattern, and I don't care that it shows a quadratic pattern, it's a curve pattern. Let me talk to you also again about residuals. You cannot, nobody can, go from a residual plot to the original set of data let me rephrase that. You can go to the original set of data, you just can't tell what the original set of data was. You can't tell if it's linear, quadratic. I cannot look at that and tell you what it was. I can just tell you what it was not. It was not quadratic because of the curve. Okay with that? But I don't know what it was. Okay, so am I saying? Okay, so I'll give you a residual plot right here, right? I heard a couple whats. So this is my residual plot. This is bad because it's curved. So then I looked and they said they used a quadratic regression. So no matter what happens, this residual plot tells me quadratic regression was not what it was. However, I don't know if it was linear or exponential. I don't know if it was linear or exponential. I just know that it's not quadratic. And so when we get to one of these other questions, maybe that'll help you too. Or come on, quit bouncing. That's why I don't like this Google on this. All right, number 6. So they said, is this where you had to find the equation? A should have been 2.267 or 268 either way. Or if you said 2675. Was that the right? Are we okay? Yes, no? Okay. B was 0.077 or 0.078 or 0.0779. Just make sure you go out at least 3. And they don't care if you round it or not, but go out at least 3. And then you need to store that into Y1, and that way you can plug and chug. There's Y1 29. So when I plug in 29, you should get 4.5274 or 5.27, 4.57. I keep saying 7 first. 4.527. But then you got to put the word billion because that's in billions. You got to put billion. So the residual should have been negative 0.0646. That means we overestimated it. Residuals do not have a unit of measurement. Residuals don't have a unit of measurement. Okay. This is the one that I thought was a difficult question. And I don't say difficult, somewhat tricky. Okay, so you can see that this is the data. It should have been exponential. It should have been exponential. I don't think there's any doubt that that's exponential. This is the residual plot. That's a bad residual plot. So whatever they did it wrong. If they did exponential, my guess is this thing would have been scattered. So whatever they did wrong. A regression model was created for the data in the given above graph. So I did some type of regression for that. The residual plot is given to the right. That's bad. So whatever I did over there, I did it wrong. Even if I did exponential, it's wrong. A quadratic regression model was used and the model is appropriate. The model's definitely not appropriate because that's curved. The model's definitely not appropriate. A quadratic regression model is used and the model is not appropriate. I like that one. The next one says an exponential regression model was used and the model is appropriate. The model is not appropriate. And it says an exponential model was used and the model is not appropriate. And I don't think they use an exponential model because if they did use an exponential model, that would have been scattered. Okay with all that? The only two possibilities were B and D. Originally, I thought the answer was D because that's exponential. And the guy should have, I mean, you guys are freaking smart. And every one of y'all said, I should use an exponential. And then it looks like that and said, So that one was B. This residual plot's good. So because that residual plot's good, the residual plot has no apparent pattern, the quadratic model was appropriate. Because the residual plot's scattered. We want the residual plot scattered. That's a bad residual plot. That's a bad residual plot. That's a good residual plot. And not only is it good because it's scattered, but it's also good because the residuals are really small. That means the points are really close to the line. Whereas these are 6, those are really bad because we're really far away. So this is the best one, and the only one of those 3 that's exponential is C. We haven't even talked about logs yet, although we will at some point. So I'm guessing at some point we'll do a logarithmic regression also. He should use an exponential model because the value of the account is changing proportionally. 1.104 per year. He should expect to see no pattern in the residual plot. Okay. Yes, no, maybe. Anything about residuals? Anything about residuals? We're good? Yes. 6, 8, 7. You got a different what? Okay, so we had to plug 40 in the equation. Part A? Oh, the regression is wrong? My guess is you plugged in a number wrong. That's pretty much the only way to get that wrong is to plug something in incorrectly. You just have to look closely. Y'all do, Desmos will do this also, right? So you go to Desmos and you go to input data and you input the data. Again, I've talked about this. I would feel comfortable with both your TI and Desmos, because on the test, you're going to have a computer screen in front of you. And if you open up Desmos, it hides a lot of your screen and it gets a little cumbersome, especially if you're using your Chromebooks. Just kind of understand all that. It works fine and it's okay. Just, you got your calculator. You can have both. You can use Desmos and you got your calculator. So you can have both. That's my guess. And again, if that was a free response question and you missed that one, of course you're going to miss B according to the actual answer. But as long as you use your equation to go with that, they'll give you points for it. And they're going to give you some leniency with that, assuming that you might put that in incorrectly. Okay, good. Anything else about this class so far, or this lesson? Everybody good? We're getting better. You guys are getting better. You guys are learning how things are supposed to be. That's all I care about. All right. You don't want Tiger Stadium announcements. Because it's here. And you don't want that key, because that's a bad key. And you want notes for 2.7. So we're going to do 2.7 today, 2.8 Friday. I sent you a nice little blurb. I hope you guys saw that, right? I think I messed up and told you like I was a week off. So 2.7 today, 2.8 Friday, review Monday. I had all intentions of giving you your quizzes back today, and that's just not going to happen. If you want to come by tomorrow and pick it up, you can, but I'm going to give them back Friday. I will give them back Friday because we're testing Monday, and that'd be kind of help you with part of your review. And I'll give you exact instructions on what to do Friday. Don't worry about that now. Okay, here we go. 2.7. That's not correct. I know that. Go away. I want you back up here. Minimize. Why did that happen? 2.7. It's supposed to be that. That's what happens when you don't prep. Let me go ahead and. You don't have all of 2.7. You don't have all of it. I don't have all of it. Where'd I put it? Here it is. Nope, not this one. You probably do not want that question. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2, 3. Uh-oh. 1, 2. 1, 2, 3. So this, I'm calling 2.7 continued. Did that still not open yet? 1, 2, 3. Oh, I did give you 3. I'm an idiot. 1, 2. 1, 2. All right. Recycle bin. I think I deleted the one I'm not supposed to. Where'd it go? Restore. How do I restore? Where's that at? There it is. Restore. And I don't know if it might be this one. Restore. Minimize. Notes 2.7. Why are you going to open for me? Just let me play Tetris. I need a return button. There you go. Enter. Does that look like it? F of 5? Go! Okay, now take 2. Consider the function. That's exactly what it looks like to start. Okay, f of x is 2x minus 3. Boy, I don't know if I can give you much easier of a function unless if I just give the y-intercept away, right? Linear function, slope of 2, y-intercept of negative 3. Oh my gosh, I wish we could go back to stuff like this. Evaluate the following. F of 5, that's a plug and chug 5, right? So 10 minus 3, you probably don't want a naked answer. You would, if they ask you something like this, guys, get a little bit pencil happy and go ahead and say f of 5 equals 2, 5 minus 3, and then we could go 10 minus 3, which, or sorry, 10 minus 3, which is 7. Okay, that's fine. But I would, again, I wouldn't have a naked answer. Homework, I don't care, but just understand tests are a little different. Now they want f of c, so that would be f of c equals 2c minus 3. And that doesn't simplify, that just stays the same. So basically I replaced x with c. This time I'm going to replace x with 4a. So I'm just going to go ahead and write it. I'm going to cheat just a little bit, and I'm going to say equals 2 4a minus 3, except that's now going to be 8a minus 3. They will want you to simplify. And so you should know that if there's 4a and I'm doubling it, then there should be 8a's. And the next one, now this is the one that students start messing up on a little bit. They want to put 2x times 5x minus 1, and it's not 2x times that. You are replacing this x. I replaced the x with 5. I replaced the x with c. I replaced the x with 4a. So I've got to replace the x with 5x minus 1. So now instead of 2x, it's going to be 2 5x minus 1, and then minus 3. And that is going to give me 10x minus 2 minus 3, combining 10x minus 5. Yes, no, easy enough, good. You will not see a question like this on your test. But this is introducing us to what we need to know today. So that's that part right here. Here we go. Go away so I can move you up. Composite functions. Sometimes in math, we'll plug a value in for x into a function that uses an output, uses that output to plug into another function. When we plug an output of one function back into another function, a lot of the words are left out on this, it's called a composite function. So let g of x be 3x plus 1, g of 2 equals c, find g of c. That's a stupid question, but okay. So g of 2 equals c, I want g of c. So g, got to go back to a pencil. Let's change the color. G of c equals 3c plus 1. G of 2 still equals c. I don't think I need that. Here's g of c. Okay, good enough. Hit me.
So you find g.
I hate when y'all are smarter than me, and that happens so much. I got a math degree. So what am I doing? Plugging 2 for that. Okay. Do that, turds. Plugging 2 for that, because it's g of 2. 6 plus 1, 7. And then I'll find g of c, which is 7. 2, yeah, because it's a constant. Huh? Good gracious. Shut up. This I know, you don't, maybe. There are 2 ways that we can write composite functions. You will see them either way. You will see them either way. I like one a whole lot better than the other one. And the one that I like is the one that they don't use the most often. But who cares? I'm going to just use G and F. Golf. G with a little circle right in the middle. It looks like a multiplication symbol, but it's not a multiplication symbol. It's an actual circle. But it's kind of as small as a multiplication symbol. G of F. G of F. And the other way that you will see it is G of F. Both of these functions do the same thing. Oh, we read these as G of F of X. I probably shouldn't have put an F. G of F of X. G of F of X. This one doesn't put the X with it. Sometimes it will, sometimes it won't. Sometimes it will, sometimes it won't. That one they will. I like that one better than this one because this one sometimes looks like multiplication and gets me confused. But they use this one more than they use that one. What that means is you start off with F of X, whatever it is, and whatever you get for F of X, you're plugging into G. It's just like order of operations. You start with, you do what's inside the parentheses first, and then you got to do second. Do F first, and then do G. Okay, beautiful. Oh, when working with composite functions, we start on the blank right, on the, I don't know, far right, second right. Start on the right. Start with F and start with F of X. I don't know what they want right there. If given F of G of X, evaluate G of X first. This I know for sure. Sometimes I think the notes make it harder than it is. Use the answer from G of X and plug into F of X. Okay. Everybody okay with notes? I'm surely you've done composite functions before. I think we messed up and put a composite function on the quiz. I think that was the first question. Nod, yes. Okay. F of G of 3. Again, how you say it makes you sound a little bit more intelligent. Don't say F parentheses G parentheses. No, F of G of 3. So we're going to start off with G of 3. And so then I'm going to go up here, and that's F, so I don't need to start with that. I'm going to go over here with G. Okay, so I'm just going to do G of 3 first. G of 3 first. So instead of G of X, I need G of 3 is equal to 2 3s plus 1. Is that the same function we started with? No, it was minus 3. 6 plus 1 is 7. So G of 3 is 7. So really what you're doing, guys, is you're replacing this G of 3 with 7. Because that's what it is. G of 3 is 7. So if G of 3 is 7, then I'm going to replace G of 3 with 7, and now I'm really doing F of 7. So now I'm going to do F of 7. Green. So F, didn't write F, of 7. And now I'm going to go up here and I'm going to do 3 7s minus 5. And that's 21 minus 5 is 16. I circle my answers out of a huge habit. You guys probably circle answers out of a huge habit. I wouldn't circle answers. Try not to circle answers. Because what that does is focus that grader in on that 16. And if it's wrong, then they already have in their head that this kid did it wrong. Does that make sense what I'm saying? And you now, because you got to understand, these guys, these graders, I don't grade stat. I grade stats. I don't grade pre-cal. But Miss Mims is graded pre-cal. And you got to understand, we're trying to grade like 200,000 papers. There's 200 of us in a room, and these papers are coming across as fast as we can. And so we're just going as quick as we can. Did they get it right? Did they get it wrong? And if you got this thing right here, now we got it in our head, oh, they did it wrong. You don't want them to get in their head they did it wrong. You want them to look for their answer. Kind of, you good with that? Just I would get away from circling answers. So now I want to do g of f of 3. This time I'm going to start with f. Start with f. So f of 3 is f of 3 is going to be 3 3s minus 5. 9 minus 5 is 4. So really I'm replacing this with 4. And then I got to do g of 4. And so g of 4 will now be 2 4s plus 1, which is 8 plus 1, which is 9. And now, like I said, without me circling that, I'll see that 9, but then I even backtrack a little bit and I'll see g of 4 equals, and that's kind of what they want, is they want g of 4 because we need g of 4 because we needed f of 3 first. And then this one is the one that starts to get a little bit more confusing, I guess, because it says f of 4. So that means I got to do f of 4. So I got to do f of 4. So plug and chug 4 into 3 4s minus the 5. 12 minus 5, 7. 7, 8, 9, 10, 11, 12, 7. Sorry, I'm a finger counter. And so now I just got to do f of 7. These get to be a little confusing when you start plugging in themselves. So f of 7 now is going to be 3 7s minus 5. And 21 minus 5 is 16. Yes, no, somewhat, maybe. Composite functions. Composite functions. Use equations f and g for example 2. Now this is more pre-cal stuff. This is more algebra 2 here. This is a little bit more pre-calish. Let's go back to, so this time it says f of g of x. To me, it's easier to somewhat do this. Okay, it says g of x, so I'm just basically going to replace g of x with what g of x is, which is 2x plus 1. I'm going to replace g of x, which is 2x plus 1. Now I got to plug 2x plus 1 in place of f. Yep, sure, you don't have to ask. 3, 2x plus 1. And then I got minus 5 still. Don't forget the minus 5. That's a bad habit for students. They get into a rush and they forget the constant at the end. And so now this becomes 6x plus 3, but then I have the minus 5 still. We want to simplify that better, so let's make it 6x minus 2. Okay? G of f is the opposite of that. So let's plug and chug that one. Instead of g of f, I'm actually going to replace f with what f is, which is 3x minus 5. And so now I'm going to plug 3x minus 5 in place of the g. So it's 2 instead of x, it's going to be 3x minus 5. Again, don't forget the constant. That's going to be the uh-oh if you make an uh-oh. Most students do really well on this, except for the uh-ohs there. So that's 6x minus 10. But then I still have a plus 1. 6x minus 9. Everybody good? Again, I like to put an equal sign right here and an equal sign right here. You don't have to write that down every single time, but you like to keep things lined up. So I should have an equal sign here and an equal sign here. And again, that just helps the grader. That just helps that grader know that, hey, this right here is coming straight down here. I got my equal sign lined up. It just makes things look nice and neat and pretty. And the nicer and the neater and the prettier things look, the easier it is to get your full marks. You want to get full marks on something that's easy, for sure. Okay. Am I still going like your paper? Is everything looking the same? Given the functions above, find the following. There's the one that's written a little bit different. That's written, so that's h of m of -1. Okay, so you do m of -1 first, then plug it in for h. Do p of x first, and then do that for k. So those are the of ones. I mean, the circled ones. I like them like this better. I never saw them like that till college, and then I guess that's why. Y'all good? Start plugging and chugging. See if your answers match my answers. So do A, B, and C fairly quickly or by yourself or however you need to. H of 2, 6 minus 3 is 3. 9 plus 12 plus 5, 21, 26. Yay? You guys that worked ahead? Yeah? See, what I asked. 4 minus 3 is 1. Cuss. That's going to get all this wrong. First mistake this year. Well, that's really nice. That makes this a whole lot easier. 1 plus 4 plus 5. 10. Now we're better? 4 minus 3, 1. -1 for m. Where's m? It's all the way over there. H, -1, -3 plus 2, -3, -3 plus 2, -1. I'm not going to mess up again. Well, that's weird. M of -1 is -1. So H of -1, where's H? -1, -4, -3, -7? Huh? That's what I said. You try to figure out what that is. Guess what they'll do? Count it wrong. They can't figure it out, they're going to count it wrong. If you put 2 answers, they're going to count it wrong because one of them's wrong. Y'all follow what I'm saying, right? If they put 2 answers, they call those parallel answers. And parallel answers, they got to count it wrong because they don't know which one's right. Because you don't know which one's right. And if you don't know which one's right, then they're going to count it wrong. So don't ever put parallel answers. You don't have to erase. You can put an X through it. As soon as you put an X through it, the grader cannot grade it. So you can save yourself some time and just put an X through it and continue on. Again, I'm talking like on a test, right? Yes.
Would it still be correct if you do like H and then you for X you plug in like M, and then after you get that?
Yep. She's asking this, so instead of doing -1, if I actually take M and plug that in for H, and then work that out, like plug in -1 one time, y'all follow what I'm saying? If I did H of M of X, then I'm going to take M, 3x plus 2, plug that in for X here, double it, combine it, and then plug in -1, you'll get the same answer. You'll get the same answer. I think this is way a little easier, especially because of the quadratic, because you don't want to square a 3x plus 2. What did we decide this was, -5? You probably want a little bit more work than that if it was a test. You probably want a little bit more work than that. However, that's not that bad. Yep.
So I did the way where you plug in M and then afterwards you
Yep.
multiply it, and I got -6x.
Yeah, because then you got to plug in -1. Good? Everybody else okay? Oh, I don't need that. I need to change colors. Green. I like green. Bless. Oh, this one's K of P of X. Yuck. K of P of X? Holy cow, they went from simple, simple, simple to hard. K of the square root of 3x plus 1. So now I got to put that in place of K. Ugh. Oh, yay, I'm squaring it. So if I square the square root of 3x plus 1, I'm going to get 3x plus 1. And then I got to do, I'm going to run out of room, plus 4 parentheses, square root of 3x plus 1. this is going to be bad. I got to go down here. 3x plus 1 plus 4 square root 3x plus 1 plus 5. If you're worried about simplifying this wrong, leave it. You're better off leaving it than simplifying it wrong. There's like different points for a wrong answer or not simplifying. Y'all follow what I'm saying, right? There's different points, subtraction. So not simplifying is different than getting it wrong. But this one, I think you should be able to simplify because you can just, all you can do is put the 5 and the 1 together. You can't do anything with this. You cannot distribute the 4. You cannot do anything to that. And that 3x, you can't do anything because there's no x's. There's a square root of 3x, but then the square root of 3x has with the 1 to it, so you just can't do anything, but you can put the 5 and the 1 together, make it 6. So 3x, and they don't care what order you put them in. There's no such thing as a standard order. Plus 4 root 3x plus 1, and then I'm going to close the parentheses, plus 6. And if you want to put 3x plus 6 plus that crazy stuff, you can't. They don't care what order you put it in. Just make sure it's right. I like the equal sign. Equals, equals, especially when it doesn't go in order. You guys have seen, though, on tests, you have plenty of room. Plenty of room. Worksheets, you may not. Tests, you got plenty of room. More than's needed. All right. This one, guys, you got to hit me.
I'm still confused. Phone number B for that last one. And let's see. It's not, how is it of -1 instead of multiplied by -1 and multiplied by x?
That's just the rule. That's just the way they act. It's just, y is a square root to square root. y is only the x squared. Because only the x is squared. I mean, it's just, that's the rule.
So why wouldn't it be written as?
Because that's the way they write it. That's why. I don't like it either. That's why I really hate it like this. Because it looks like you should distribute the -1. But you don't because of the of. Great questions. And again, that's the confusion. I don't want to say I don't think this is that hard. It's just a different notation. It's just new ways of looking at things. That's what happens as you guys progress in your mathematical career. You're going to start seeing, therefore. That's the mathematical symbol for therefore. It's a whole lot easier than writing therefore about 800 times when you're trying to make a proof. It almost equals, or about equals. You've probably seen that one before. Good. So yeah, that's just the symbol. That's just the way they do it. Because, I don't know, go back and kick that guy's butt. Yep. You can, if you want to get it wrong. Why do you not square the 3? You don't have to have the parentheses. You could make it 4 root 3x plus 1, but there's no way to put a 4. You can make it 16 and put it inside there. But that's not any simpler. You can't distribute the 4. Y'all hear, she's asking why can't I not distribute the 4? You don't have to have parentheses there because that down below it says the same thing. But if you put them there, it still says the same thing. Now, if you want to put the 4 in there, you got to make it a 16. And then you can distribute, but now you're starting to do stuff that's, you're not making it look any better. Yep. Oh, that's right. Everybody else okay? Great questions. Man, I love this. Because somebody will try to do that. I understand. I know. You guys try to make magic math. There's no such thing as magic math. All right. Beautiful. Let me erase this stuff. That needs to go away because that's extra. because somebody might look at that and say, what the heck is that? All right, this one, we're starting to get up there a little bit here. Recognize what this is F. What is F? I got no clue. It's a piecewise function. It's got linear, constant, constant, linear, point, whatever. I just did one. It could be 1, 2, 3, 4, 5 pieces. That's a 5-piece piece. Who cares? There's G, which I don't know what that is. I guess I could do some math and figure. No, it's got a pi in there. Who knows what the heck G is? And there's H, another piecewise function. It's got 3 pieces. Y'all okay with all that stuff? You got to recognize which one's F, which one's G, and which one's H. K of X, K, where the heck is K? K of X is a quadratic function. Oh my gosh, holy cow, man. This Passwater dude's a jerk. K of X is a quadratic function with a horizontal translation of 2 followed by a vertical translation of -3. Man, you got to know that K of X is equal to X minus 2 because that's a horizontal translation of 2 and then a vertical of -3. And you just got to know that because we did translations last chapter. And we're not done with translations. We're going to continue to do translations. Luckily, we don't have any dilations. If we had some dilations, that'll make it even worse. But just horizontal translation, it has to go with the X, opposite of what you think. Remember, everything with the X is always opposite of what you think. And then the verticals are by themselves. All right, here's example number 5. I'm going to have to go up and down on this. F of G of 3. F of G of 3. That means I got to start off with G of 3. So I got to start off with G of 3. G of 3. I don't have a G of 3. Do I? Am I looking at this wrong? I can have 2 same outputs. I guess can't have same inputs. She asked why do I have 2 of the same outputs. I can have 2 same outputs. Quadratics have 2 outputs that are the same. I just can't have 2 inputs. You can't write an equation because it's got a stupid pi in it. There's no way I can find an equation for that stupid thing. Yeah. They're not going to do that. Nah, they're not going to do that. Yeah. Oh, if possible. Read the stupid instructions. I knew it did that. I was hoping somebody else say that. Luckily, that was not a mistake. I was hoping somebody else caught that. Because that's what we do, or that's what you guys do. You go right into it and say F of G of 3. Good? Because you don't read the question. The graph of the function F is given a love with the selected values of the function. G is an equation, with the selected values. G is an equation of piecewise function H and a verbal description of K. Use this information to evaluate the following if possible. That's not possible. I don't have a G with an input of 3. No idea what it is. No idea what it is. So, now I know this answer. It ain't possible. I can't do it. Nobody can do it. Archimedes, I can't say. Archimedes, he can't do it. He's got invented calculus. He can't do it. Nobody can do it. H of F of 8. That means I got to start with F of 8. F of 8. F of 8. F, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. When I put input of 8, I output a -1. I can do this so far. I can output a -1. When I input a 8, I output a -1. So now, instead of this being h of f of 8, it's like h of -1. And again, I'm just going to write it like that. Because when I inputted an 8 on f, I outputted a -1. Now I got to go to h and find a -1. Oops, I got to turn that back. Find a -1. Find a -1. This is if x is greater than 1, if x equals 1, and if x is less than 1. So x is less than 1 is here. Good gracious. So now I got to plug in -1, and -1 times 3 is -3. -3 and -7 is -10, but then I got to take the absolute value of -10 and get 10. And if this was a test, I would show a lot of those steps. I would not do it in my head. Fair enough with all that? Because if you mess up and all you put is 10 and it's wrong, I can't give you any points at all. It's impossible to give you points. You still may not get points, but at least if you show some work, you might get some points. Beautiful? It was 10, right? Is that what we said? Was it? It can't be -10 because of absolute value. Everybody else okay? Good? And now I need g of k of 0. Oh, k of 0. Well, I know I can do k of 0. 0 minus 2 is -2. -2 squared is 4. 4 minus 3 is 1. Whew. So I got to do g of 1. And again, I would plug in 0 and just show that. I would, and now, go ahead. 1, g of 1, g of 1, g of 1, a, b, c, d, g, g of 1, g of 1. Did I do it right? Is it 1? It's going to make me second guess myself because what? I don't know what the heck g of 1 is. So I don't think I can do that one. Can't do. F of 2. Ooh, that's like a calculus question. F of 2, F of 2, F of 2, F of 2. Oh, I got to, it's not 4. That's a whole. So F of 2 is 1. So F of 2 is 1. And now it wants me to do F of 1. F of 1 is 4. I kind of like the graph ones. 4. G of h of 1. 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 H of 1 is -4. H of 1 is -4. So now I got to do G of -4. I can do that one. Pi. Pi. Oh, what? G of f of h of k of 3. Might as well ask that one first. If you can do that one, you can do the rest of these. K of 3, K of 3, K of 3. Oh, K of 3, K of 3. 3 minus 2 is 1. 1 squared is 1. 1 minus 3 is -2. -2 for h. -2 for h. God, you miss one of these, you're missing everything. That's why you got to show your work. Maybe you get something. What was it, -2? -2 is -6. Oh, crap. -6 and 7 is -13. Absolute value of -13 is 13. We're good? Is it 13? So now I got to go to F. F of 13. I'm done. Can't do F of 13. I don't know what it is. Everybody okay? Beautiful. Beautiful. Okay, let's continue this on for just a little bit. These are more AP-ish type questions. He added to these notes after we printed the notebook. And he's added to a lot of these notes, but we only think these might be worth it. A lot of these we don't think are worth it. We think this one was worth it. This figure shows the graph on the domain from 0 to 9. So here's 0 to 9 of f. G is given by this crazy function. I mean, it's cubic, but that's about all I know. It's crazy. Probably doesn't have any intercept, or it has an intercept, but I'm not going to find it without a calculator. The function h is defined as h is equal to g of f. Oh, they did both. Y'all see that, right? So there they did the little of, or the circle thing. The golf thing is what I call it, golf. And then g of f. Find the value of h of 6 as a decimal approximation, or indicated if it's not defined. And so that's a typical type question if it was calculator. Because of all these darn decimals, this almost has to be a calculator question. So h of 6, h of 6, h of 6, h of 6. This one, oh, I'm sorry. Find the value of h of 6. H of 6 is g of f. So I got to go to f first. F of 6. F of 6 is 1. F of 6 is 1. And so then I got to plug in 1 into that function. And that becomes a little finger exercise. 1.2 times 1 cubed. 1.2. I may not even need I don't guess I need a calculator for that. 1.2 minus 4.7 plus 9.62, and whatever the heck that gives me. And I'm not doing that by my head because you guys got calculators. But I could. Example number 7. This is a good question. I remember this one a couple years ago. The table gives the values of the function of f and g. So here's x, here's my inputs, here's the output if it's f, here's my outputs if it's g. X, functions f and g are defined for all real numbers. So f and g are defined for all real numbers. That means the domain goes from negative infinity to infinity. Let h be the function defined by f of g of x. What's the value of h of 1? So h of 1 means I got to plug in 1 for x's, and h of 1 means I got to do g of 1 first. And g of 1 is 0. And if g of 1 is 0, then that must mean that f of g of 1 is f of 0, and f of 0 is negative 1. B. B. Oh, yeah. Told you. This was easy, they'd call it algebra 2. Oh my gosh, there's a quadratic f and a linear g. Oh my goodness gracious. This is, man, you see why we added this? Everybody thinks it's real easy, and then I give you this one. It's not. So I got to plug g in for f. And so f of 3x plus 5. 3x plus 5 squared minus 3x plus 5 plus 7. Five squared is 25. 25 minus 15 is 10. 10 plus 7 is 17. I cheated. I figured out what the constant was. This is going to be 9x squared plus 30x plus 25. Square the first, multiply those two together and double it, square the last. You should be pretty good at that. If not, write down 3x plus 5 and another 3x plus 5. What are a lot of students going to do? They're going to get their stupid head chopped off, and they're going to make that 9x squared plus 25. They're going to forget that. But ironically, when you write 3x plus 5 and another 3x plus 5, when it's written like that, we don't forget the 30x. When it's written like that, we do. So if you have to, write it like that. I'm just telling you, 28 years, I know where you're going to mess up. And that's where I don't see a lot of 30x's, but when it's written like this, you don't. And then you got to do a negative 9x, and then it's a negative 15, and you got a plus 7, and then you're going to simplify everything. Well, I just knew that this was going to be 25 already. and I knew that this was going to be negative 15, and I knew that was going to be 7, and now I'm not lost my connection to my board, but 25 minus 15 is 10, and 10 plus 7 is 17, and there's only one of those that has 17 in it. Y'all kind of okay? Sometimes you can use your answers to help you. You don't have to do the whole thing. Now, if there were 2 17s, I'd have to do some more. Is that the last thing? I hope